So tonight we just want to give you an update and, as usual, open it up for questions so that you can ask every question that springs to mind, and we'll do our best to answer them as clearly as possible. I'd like to first introduce a few people here. So Jim and Peter and Ian, they will talk later, and of course Mike. So the community engagement is important to us, and we want to be as open as possible for people. We've got Marie here from Nelson Mail, and Marie tracks us pretty carefully as to what we do and say. So yeah, it's please feel free to ask questions. I'm sure you've got heaps of them. If I could pass over to Mike, our CEO, and he's got a presentation to run through first, which might answer some of your questions, but they also might create more questions. Thank you.
Thank you. Yeah, tēnā koutou katoa. Good evening. Thanks for coming out on a winter's night. I thought tonight what we'll do is just go through a few slides to give you a bit of an update on where we're at, and hopefully answer a lot of your questions that you have, and then at the end of tonight we'll come back to questions and address anything we haven't. So I thought we'd start by describing COVID-19, what that's meant to the project, and then we'll talk about the money and the progress, and where we're at with the budget. I want to talk about safety and the environmental work we're doing on site, and then I'm going to ask Ian, our design and engineering manager, to talk about the rockfill issue that we've had on site, and particularly around the geology that we've encountered, and provide a design update, and then between Jim and myself we'll provide you with a bit of an update on construction and show you some pretty cool photos, and then we'll sort of go to questions at the end. So with that, before I start, let me just quickly describe our wider team to you. We have a lot of high-powered people working on this project. There's a lot of expertise working on this project, other than myself. So clearly we have the Waimea Water Limited team and our board, as you can see in this photo down below. But we're also supported in our design work by Damwatch Engineering. That's Peter Amos and his team. Peter's here tonight, and their job's to effectively give us a PS1, a producer statement number 1 for any design, and a PS4 for the construction. The peer reviewer for design is GHD Engineering, which you may have come across. So GHD Engineering do the design review, PS2. They're also supporting Jim's team, Fulton Hogan Taylors, with the design of the temporary works. So between Damwatch and GHD, you've got a lot of dam engineering there supporting us. Stantec, another engineering company, are engineer to contract and help us with the engineering. Fulton Hogan Taylors, it's Jim and his guys are building the project. We have Rawlinson's, our QS, and then we have a bunch of support from some professional services in the industry. So the point I'd leave, go Matt. The point I'd like to make here is you've got a pretty strong, robust team on all aspects of this project to make sure that we get a really good quality, well built dam. So let me start with COVID-19. As you all know, we went through level 4 for 5 weeks, and that stopped work. We had to suspend work. We believe that under the MBIE guidelines we could have kept going, but we ended up suspending work for 5 weeks, and then we took a week to remobilise, put in place the additional protocols, facilities, portacoms, to ensure we could work at distance from each other. And then there was a pretty slow start-up as we sort of got into the new working regime. So we pretty much lost 2 months and counting. So the and counting part is we are seeing constraints and disruptions to the international supply chain. COVID-19 seems to be affecting countries around the world in different ways at the moment, and getting spares and machineries and parts out from around the world is proving a challenge. The net effect is essentially, COVID-19 has been one hell of a kick in the guts to us. It's probably tipped us over the season. So we were 2 to 4 months beforehand, which was very tight. We're right on the season. We were relying on that beautiful weather during March and April, when we had fine days, it sort of barely rained in that period, sunshine, to recover some of the program. We lost that opportunity, and so we're now 6 months behind effectively on the project, which means we lose that 21-22 season. So it's been a blow to us. Look, we are looking at ways to recover, and we'll come back to that shortly. Jim and his guys are working really hard on ideas to try and recover part of the program. It's a stretch. We've only got 1 year, 4 months to go, and we're significantly behind. I talked about the supply chain, the spares and parts. Just by way of example on the supply chain. Matt Taylor, who's the tailors who do a lot of the earthworks on site, he bought the last 6 tyres in New Zealand for an ADT. Right, so he's got all the last tyres available for his trucks. If he had a 7th blowout, he's got a problem. And so that's how tight the supply chain's getting. We don't yet have a view on where the costs are. So the costs are going to be sort of resolved as an industry. So it's going to take some time. I mean, I hate using the word unprecedented because I hear it every hour, but that's the reality. Is that there is just no precedent for this sort of event, and there's going to be the whole industry is trying to figure out how to resolve it. So we're looking to take our lead from the rest of the industry. It's going to take a while. But what we will do is we will report on the time and cost associated with COVID-19 as we go through our reporting season next year. Look, with respect to cost, so since we last had an opportunity to meet, you would have seen the announcement that the costs have increased by $25 million, really associated with the performance of the rock in the rockfill, and we'll come back to that. So the cost is really around the geology that we're encountering, and so that $25 million effectively comes as an additional TDC equity here. That's this bar here. So you can see here our source of financing is really from the will equity and the will loan, the irrigated loans, then the TDC equity, and then TDC equity courtesy of some grants, obviously from the Ministry for Environment, Nelson City Council. So there's a bunch of, I think it's $12 million of grants that they get, which converts into equity, and then the additional equity is $25 million. So that really supports the cost increase in the project. With respect to spend on the right-hand side there, so you can see we're a bit behind, we are behind the forecast because we're late. We've spent $50 million to date. We'll probably go past our forecast spend in July this year. We'll go past our original budget at 104.4 in about August 21, and then we see ourselves sort of coming out at 129.4. So we've held that number since the start of the year. I'm often asked about spend versus progress. Well, they're pretty much aligned. We're coming out 40% spent at $50 million. That's this bottom bar here. So we spent $50 million. And then we have the remainder of the budget to go. You can see the original budget and you can see the additional spend. And progress-wise, we're 16 months through, so about 40% as well. So time and money is roughly about 40% spend and correlating together. So you may have seen this in some in our mid-year report or SOI, statement of intent. This provides just a cost overview. So right now, as I said before, we're looking at $129.4 million as where we see costs right now, and that's based on what we know now, right? That's based on what we see today. There may be some wins in front of us. There may be some more costs. We've looked at all the risks we can see in front of us. We've put some evaluation around it. There's a fair chunk of risk money in there, but it's just based on what we can evaluate now. And you can see that a good chunk of that 16.6 is really around the geology we're encountering. So it's a combination of bringing in some drainage rock, which you'll hear about shortly, some of the voids and holes are seen in the plinth, and additional stabilisation. And we have around about $3 million of unallocated contingency remaining. With respect to the program, look, as I said before, COVID-19 was really brutal to us. So we're 6 months behind, which is about a season, is where we see ourselves. So we've lost that 21-22 season. We're currently working, as I said before, Jim's working pretty hard to find ways to recover part of that program. One of our key constraints before COVID-19 was resources. You just couldn't get people. I mean, everyone's busy. Unemployment was at a record low. We couldn't get skilled resources, tradespeople. Everyone's busy building houses. Post COVID-19, there may be an opportunity to employ some more tradespeople. So, we're talking to the construction companies, and if they have people available, there could be a win-win opportunity here where we could help support the local economy and people working while actually helping recover part of the program. And that's something that Jim and his guys are currently pursuing. So with respect to performance on site and the project, look, I think one of the real highlight to me right now, and this is the bit that I think is really worth congratulating Jim and his guys on, is that we've just gone past 500 days and there has not been an injury on site. That is an outstanding performance. I've never seen performance quite like that before. The mentality of the guys on site about safety is just top shelf. And a big shout out to Jim, Charlie in the photo there with their safety performance. It's been a great effort, and if there's one thing that keeps me awake at night, it's people staying safe and not being injured on site, and these guys are doing a great job. So here we are celebrating 500 days injury-free on site with a barbecue breakfast at 5:45 in the morning before we start work. It's minus one or -2, so it's pretty chilly. And the folk really appreciated the recognition. Just a couple of graphs on the right-hand side there. We do a lot of audits on site, safety audits on site. Jim's guys do. We have our own independent audits and track how the team's performing. The bottom graph there is really our injury rate, which is a flat line at the bottom. We had one high potential incident last year with rockfall. That was a free lesson to us, and that was the one incident we've had so far. So it's a great performance, and touch wood, may it continue. I'd like to talk a little bit about the environmental performance. I hear a lot of people ask about the river, how does it affect the river, and there's a bit of chat around sediment in the river. So it's probably just worth touching on this for a while, because I don't think we've ever talked about this before. But we have a pretty onerous resource consent around river quality and environmental works. So you can see here in this photo, this is the diversion bund, and you can see the river flowing down beside it. It's pretty clear there. So the 5 environmental management plans are all approved and in place working. that pertains to construction, environmental management plan, the traffic, biodiversity, hazardous, and vegetation clearance. And then the supplementary environmental plans have all been put in place, approved, and are working, and once again get verified. And what the graph on the top right shows is the number of audits, inspections that are conducted every month. So you can see that between a combination of Fulton Hogan's own head office out of Christchurch, the regulator TDC, our own, and we use an independent party called SLR as well. You can see we sort of go between 5 and up to 12 audits a month on water quality. So there's a lot of environmental auditing to ensure we comply with the consent. The graph at the bottom is a measure of life in the river. So it measures river life, and if we need to stay above the yellow line essentially. What you can see here is the blue dots are upstream of the site, and the red dots are downstream, and you can see that before construction was very similar to after, during construction. In fact, there's been no real change at all in the life of the river. The only dip was before we started, which was in that drought early last year. What has been a bit surprising is sometimes there's more life in the river downstream of the site than there is upstream of the site. Still on the environmental front, so we measure the pH in the river, and you can see the graph at the top right. We're right inside the railway tracks. It's spot on, so no issues with pH, full compliance. The graph at the bottom measures the deposited fine sediment, and once again it's below the blue line there, so we're in full compliance. The key here is to measure the difference between the upstream blue dot and the downstream red triangle, and you can see that it's very close, and the sediments being within the consent. This is a photo of Emma from SLR. She goes out every 2 weeks and measures the water quality for SLR and reports back to us using a range of tests. So, message I'll leave you with is, we're in full compliance with the resource consent, and we're doing a lot of verification to make sure we do what we say we're going to do. Right, so I thought we'll turn now to an engineering perspective and talk about the rock. So I'll get Ian to talk about this. Since we last met, we've had some issues with the rock, and this has led to part of the cost increase. So it's probably worth just taking a little bit of time to describe, firstly, what the issue is and the problem is, and I'll get Ian and Peter to explain it to you, and then what we're doing about it. So, Ian.
Thanks, Mike. So it's probably fair to say the rock quality issues that we've had out on site have probably been one of the biggest concerns that we've had certainly over the last 6 months, maybe even longer. And this slide we have here sort of illustrates that quite well. What we'd hoped to have was something nice and free draining like the rock over on your left there. But once we excavated that, processed it, and compacted it into these trial embankments, we found that wasn't the case. The rockfill was quite dirty, not free draining, and it sort of didn't fit the requirements that we had for the dam. Fundamentally, what we want is something that's strong, stiff, and free draining. To support. Yalda's a very thin concrete face on this dam. We don't want that to settle. We don't want it to move. But if it does settle and move, then we want it to drain any water that gets in the embankment down and out. So we've spent a lot of time working with the designers, Peter's team, and also with Jim and his team to sort of refine the design and the sort of processing and placement methodologies to come up with something which will achieve what we need to achieve. From the series of trials and further drilling investigations that we've done on site, we've sort of come to discover that there's actually a lot more argillite, siltstone and mudstone than expected. We had expected about a 50-50 mix of argillite and greywacke, siltstones and sandstones. But once we've opened up the ground, we've found that to be closer to 70% argillite and 30% greywacke. And you can see in the photo on your left down here, the argillite's got these inherent foliations, incipient foliations, the geologists call them, which is sort of a function of how the rock's formed. It's a sedimentary rock, it's sort of formed in layers. But unfortunately, this argillite hasn't undergone enough metamorphism. It hasn't been squeezed or heated enough to remove those. And the issue that we found is once that's excavated, screened, dumped into a stockpile, picked up again, hauled out to the site and compacted, it's sort of breaking down quite significantly, like we saw on that first slide. Next slide, please, Andy. So the design work which Peter and his team have been busy working on has been to come up with a solution to make the most use of this rock that we have on site, also achieving the objectives that we have of maintaining a stiff and free draining embankment. You can see in the top right there, that was a design at the start of the project which had assumed we had stiff greywacke rock, free draining material. So any seepage that did get through that concrete face would sort of get down and out of the embankment. With the rock breakdown issues, we identified a need to actually put in some higher quality drainage zones, which you can see in the bottom left here. That sort of led to a sort of beefed up drainage behind the concrete face and a sort of beefed up drainage zone along the bottom there. By focusing on getting some really high quality material in there, it allowed us to construct the rest of the embankment from the native rock that we found on site. So we've been working very closely with Jim and his earthworks team to identify sources of rock on site. I've had a few investigation programs to have a look for that material, and have also been making inquiries with local quarries to supply good hard rock for those drainage zones. So it's been very much a work in progress, the rock issue. We think we've got the design nailed down, and over the next few months we'll be sort of working even more closely with Jim and his earthworks team to sort of perfect that methodology and construction practice. Another key bit of design we've been quite busy with over the last 6 months has been looking at the spillway, particularly in light of some recent quite high-profile international disasters. You can see over on the right there, it's Oroville Dam in California, which failed in 2017. There's another notable example at Waimea Bridge in the UK, which you may have seen in the news towards the end of last year. Actually had the army out with Iroquois helicopters dropping sandbags into the spillway to try and stop the downstream impacts there. Both of those disasters were examples of sort of poor drainage beneath the spillway and poor anchoring. So the spillway slabs again are inherently quite thin. We rely on anchoring those down to the foundation rock to keep those in place while the spillway's flowing. So one of the sort of early design issues that we identified was, probably to be fair to the original design was done before the Oroville disaster, and the findings from that Commission of Inquiry over in the States. And sort of in the interim time between the design being completed and the findings from this disaster, the sort of state of practice in the industry had moved on to require sort of much bigger, more frequent drains and bigger and beefier anchors to keep these things safe. So the Dam Watch team have developed a new design with revised drainage, revised anchoring, and also about the time we were commissioning that work, we had discovered some issues with the topography and also the topography and the rock quality, which I think we talk about on the next slide, Amy. So you can see on the sort of top right there, there's a red line which sort of indicates the side of the spillway. Rivers down on the left, and you can see it actually crosses over a bit of a void, which we can also see on the bottom part here. The void just up there, and it does actually feature in the survey down there. That's the topographical problem I mentioned, which seems to be a function of the LiDAR survey that previous design was based on. So the LiDAR survey was undertaken when the area was sort of quite heavily vegetated and didn't seem to very accurately represent the actual ground profile. So the piece of work that Dam Watch have done for us there was to design some vertical walls for the spillway rather than the raked walls that we had previously. The raked walls relied on having some topography there to construct them on, whereas this new design we've now got some vertical walls which sort of fit neatly into the foundation. And the other piece was around the rock quality that those raked walls would have been constructed on. So there was a risk, if you follow that red line there again, there's a risk that there wouldn't actually be high enough quality rock to construct the raked walls on. But by switching to those vertical walls, we've sort of removed that reliance on having rock beneath those walls. Another key piece of design we've been developing over the last little while has been the completion of the mechanical design. The Dam Watch and their sub-consultants, MTL, have done some pretty significant work to design that. And you can see a nice little 3D model over on the right-hand side there of the outlet arrangement. Those fixed cone discharge valves. And there's also a little body of work to assess tie-in to a future hydro station, which are these blue lines coming out of the bottom of the model there.
How many megawatts will that be?
I don't know the details. Mike's probably be closer to that than I am. The question was how many watts would the future hydro be?
We'll come back to it.
Next slide. So we've also been looking at opportunities to, Mike spoke about opportunities to reduce costs or speed up the program. We've also been looking at opportunities to maximise the benefit from the dam as well. And one such opportunity we're looking at here is the addition of gates on the spillway, known as fuse gates. So these are a fairly low cost element that we can add to the current design, which allow temporary storage of water above the spillway. And the real benefit of that comes in increased utilisation of that future hydro scheme. So just to summarise a few numbers there, if we had 2.3 metre high gates in the spillway, increased our storage by about 15%, which is an additional 1.5 million cubic metres of storage, which you could then use to increase the utilisation of your hydropower, or potentially to increase the reliability of your water supply, or to provide further some drought resilience. That's it.
Just go back, Amy. Yeah, so you asked before about the power opportunity. So without the fuse gates, all you got is the run of the river, right? And it's a really steep hydrograph. The river usually runs at...
You have to speak up on
sorry.
hearing.
So at the moment we only have run of the river. So typically the river runs at 1 or 2 cubics, and then it rains and it goes to 100 cubics and it comes back down again. So we can't use most of the rainwater in hydro. So without storage, you're probably getting something in the low teens of utilisation for 1 or 2 megawatts, but probably just 1.5 megawatts. If we can store the water, if we can capture that hydrograph and capture the rainfall and use it in this additional storage, then we can run 3 megawatts at probably over 30% utilisation, right? So suddenly we get a pretty attractive power project. So because of the steep hydrograph, it's probably infeasible to have a hydro project. The storage is the game changer, right? The storage in the flood reservoir would basically enable power generation to happen. And 3 megawatts may not sound like much, but actually it's at peak times it's a fair old help to our region.
How much extra cost is that going to take? Like you're going to have to build some more infrastructure here, right?
Yeah, that'd be up to the power generator. Yeah. So it's we wouldn't be building it. The power generator will be building it.
So this is going to be an add-on after the project's finished?
Correct.
Okay.
Funded by who?
By the power generator would basically pay for it. So at the moment, those rights for power generation are with TDC and Ngāti Koara. And they would look to bring in a power generator, pick a company, like Contact or Trust Power or someone who know how to do these sorts of things to build the project. And they would fund it and basically operate it. And the logic is we'd get some value back out of them for that opportunity to help pay the bills.
How much?
How much what, sorry?
How much would you get?
Well, that's all part of the negotiation. We've got to see whether there's parties that are interested first.
Is anybody interested at the moment?
Well, certainly Ngāti Koara are, so they have the charge on this. So Ngāti Koara are talking to other power companies. I don't know what their interest has been.
Why wasn't it looked at? Excuse me. Why wasn't all this looked at before you started the dam in the first place? When I'm doing business, I look at all options.
Well, it was, but it was firstly sorry, got to swap over. Yes, it was, and it's already been an add-on, and we're talking about an add-on here, so nothing's changed. It's just we've found a better way to generate power by using the additional storage rather than just using the run of river, the environmental flows, which was going to give you very low levels of hydro compared to this. So 3 megawatts, about half the size of the Cobb Dam.
It's just I can't understand if you're doing such a large project, why you're going to think of all the different options.
Well, we did, that's what I've said.
When I go and buy buildings or a farm or whatever, I look at all the different options. I explore every aspect of it. Yep. Because that's where the return comes from. And I would have thought you would have known how much you could sell the base of the dam for to the hydro people.
Well, it wasn't until we actually went through the fuse gate proposition that we realised that we can get a lot more energy out of the dam than what it was immediately designed for, because it's always been designed for community water requirements and improve the river, irrigators, industry, a whole range of things. Hydro was always the add-on.
Mm-hmm.
In your previous slide, you had the mechanical engineering one, and that hadn't been priced yet, so who's funding that?
Sorry, who's funding the pipework?
the engineering side of it, the pipe, yeah, this bit, stuff here.
Yeah, we are. Yeah, so I mean, this is all apart from this blue stuff here. This is all required for the dam.
It hasn't been budgeted.
It's been budgeted, but it hasn't been costed. So there's an item in the budget for this. It's called a provisional sum. So there is a budget line item in there, but it wasn't priced at the time of the contract.
So how
What,
close
that
is
pipe
it?
work on the top there?
There was an estimate for it, yeah, but it wasn't. There was.
Joking.
Well, no, the design wasn't complete, right? It wasn't.
You gave the public a costume, how much it was going to cost, and now you've got overruns.
No, so what we're saying was that there was an
What was it?
there was an estimate for it, right? So it was an estimate for the pipe for the mechanical work and the electrical work, and but it hadn't there wasn't a contract price for it because the detailed design had not been done.
So what's it going to be?
Well, we're still working on that. I mean, literally, the prices are out. People are tendering
So the
around.
price is going to 900,000?
Well, we haven't got the prices back yet. We haven't got the prices back.
Now they're going to even cheaper.
So,
What did you budget for it then?
sorry,
What did you budget for it?
what did we budget for it?
Yeah.
It's part of the contract sum. So,
But that
So-
keeps getting bigger.
sorry.
That keeps getting bigger.
So-
83 million.
Yeah, so we've budgeted for the work, and we've identified what we think the reasonable risks are around that, and put that in the budget as well. But we've got to wait to see what comes back in from the tenderers. Look, I mean, it could be now that a lot of the mechanical workshops are actually pretty hungry for work, right? Maybe timing helps us a wee bit now with the mechanical costs.
Not building a great deal of confidence because I understand that the rock and geology was pretty suspect right from the start, and in projects I've been involved in, there was a hell of a lot more extensive drilling and core drilling which would tell you your testing of rock to destruction, which obviously hasn't happened there, or anywhere near the extent that was required. Just so you're not building a great deal of confidence in people.
Well, yeah, okay. So we'll go. I did see your question, sir. You're from Western Australia, right?
Yeah.
So it's exploration. There's always a trade-off with exploration, right? We could always do more exploration at a cost, recognising the project didn't go ahead. You would have spent a whole bunch of money. So typically, I guess councils are trying to get away with not spending too much money on exploration, given the risk of it going ahead or not. They actually did quite a few bores. I think was it 16 bores, Peter? 16 bore logs. So your question is why weren't they tested with destruction? Why weren't the 40 mil cores tested? So they, it wasn't practical to actually put a compactor over a 40 mil sample. You would have just crushed it to smithereens. What we did look at is LA abrasion testing in those samples, which is a destructive testing, but it wasn't correlating with what we saw on site. The destructive testing that did happen was the pits. So they actually dug and built test embankments of the rock. Unfortunately, that happened to hit the small section of nice sandstone.
So why, when you found that it wasn't particularly good at 40 mil, why didn't you do some 80 mil holes? And then you can test them to destruction.
So the other part of the site was, part of the site, the spillway cut was damn near impossible to get to. I mean, it's very steep, full of vegetation, and it was obviously owned by the landowners. To actually get there onto a flat site, you actually had to knock the top of the hill off first, so you had something to work off, rather than trying to hang drilling rigs off skyhooks. And we did that once the top of the hill had been knocked off and we had a flat area. We did go and do some drilling.
So at what stage did you know that the rock wasn't up to standard?
In about January this year. So we so the argillite, what we're finding, it's actually really hard to get out of the ground. I mean, we're having to blast much sooner than we thought, and it's in situ. It's actually very pretty strong, right? And then when we dig it out of the ground, out of the side of the hill, we saw a lot of fines. So for those that came along in December last year, I think we said that we were experiencing lots of fines with this rock, and it was causing us some issues. That's what we told you back in December. Then in very late December, right around Christmas time, January, we built the embankment trials, and that's when we saw the rock fail on compaction.
The drilling rig that you used, what type of drilling rig?
I don't know, Peter, do you know what it is?
You mean to do these holes that were drilled? They were a diamond core about that diameter, about,
There was a diamond bit.
yeah, but it was a core, so
Yeah.
you extract a stick of rock out of it.
So the drilling report, what did they report to you? What depth did they go to?
I don't know, do you remember, Peter?
Oh, they drilled from, so, you've got
Peter,
the
Peter,
hillside, sorry. Okay.
There's an orange square there, Peter.
Stand on the orange square. So positioned right on the top of that spillway that Ian showed you the picture of, they drilled down to where the bottom of the spillway. So they tried to drill through the material they were taking away.
Yeah.
The top piece is weathered soils, so they always anticipated taking that away. And then the zone, the layers of rock below that, they extracted core. And
When they were drilling it, did they have much problems losing water to the bit?
the records were that they you hit some feature and you lose water in the feature. You drill beyond the feature, and you're getting
What
return.
materials did they use to pump down the casing to
So
seal it? You know.
Well, the records showed that it was all water flush. There was no muds or anything used.
They've been. No, I mean to seal it, to hold the water at the rods and at the bit. Stop losing water all the time off the bit.
The holes were cased,
Mm.
so the casing went past that point.
Yeah, well, they would have gone past the casing further down.
Yeah.
What depth did they go to?
So the holes are in the order of 30 to 60 metres deep.
Mm. So when I'm trying to get at it, if they were losing water at the bit, right, it shows you just how broken
Oh, yes.
the area is and how poor quality rock it is.
Oh, well, yes, you're correct.
Yeah.
That, and if you look at a tray full of the material,
Yeah.
material they extract,
Yeah.
it's reasonable, and then there's a shattered piece, and the shattered pieces are basically from millions of years of
Yeah.
earthquakes and
Because
so on.
I've done quite a bit of diamond drilling around here in different valleys for different companies over the years, and we had no end of trouble with losing water, pumping down dynamite, all sorts of things trying to seal it, and it was because the ground was so broken, the rock was so broken, and you could pull it out and put it in your boxes, and it just quite often just crumbled away. You didn't have to hit it with anything.
And that's this joint.
And we often had to give up, you know. Yeah.
So we're giving up here.
No.
These cores the anchor, are they? Are these the anchor for the dam?
What we were just talking about,
Yeah.
they were the holes drilled during the
Talking about
investigation
rock, not the
process.
rocks, the quality of the rock, and you
Yeah,
can
yeah,
tell
no,
when
no,
you're
I'm talking
diamond
about. I
drilling
want to know
through.
what these holes are going down
Yeah.
for.
The holes that we've just been talking
Yeah.
about were during the investigation phase when they
Okay.
were trying to explore. So they
Yeah.
were exploration. The intent was to be able to extract some samples
Yeah.
and see what the nature of the rock
So did
was.
you go right down to bedrock? Into bedrock?
Well, yeah, this down to the level of the bottom of where the spillway is.
Yeah.
The intention was to see that material was suitable to build the dam.
Did you go beyond that? 10 metres?
So where the spillway was being built, they went to that level. Underneath where the dam is, they went 30 to 50 metres below the river level.
And to get to bedrock?
They were in bedrock right through that. That's
Okay.
correct.
Good solid bedrock.
Yes, this
Not
is
broken rock what we're talking about.
that's correct. And if you this is what we're positioning the dam on.
Mhm.
So the dam is excavated down to material that that's sound for constructing the dam, and that's worked out to be just about exactly where the predictions were. So the excavation has proved to match the predictions based on that drilling. So the actual location that the dam sits on, so the foundation of the dam, it's the material that was to be taken to build the dam with, which has been.
Now where that dam is, you're drilling cores down and pouring concrete in that to give it some anchor as well?
No, that's. So there is a strip in which that is exactly what is occurring, and that's like a sealant. That's to try and basically seal. And then the main body of rocks behind, they don't have a connection like that. They're relying on the sheer weight of that large, huge lump of rocks.
Sorry, there's a question here. You had a question?
No, I was just going to say about that argillite. A lot of that argillite, the sandstone would actually be in the layers of the argillite. Would that be fair comment?
It's like this thin layer. They call interbedding. So it's the formation. So it's created by ancient rivers depositing sand, and then a bit of mud, and then a bit of sand, and a bit of mud. So you get those sort of interfingerings, and that's
where half the problem is for you, isn't it?
it is a real issue. There are places where there's been clearly a lot of rivers deposited a lot of sand, and that's hardened up and become a nice piece, but all around it is this fingered up stuff, which is the problem, as you call it.
So when you
Didn't
build a
your
stem up,
initial drilling show that you had poor RQD values? In fact, I think Damwatch did a re-evaluation of the original analysis and said that they put a shine on it, basically. In other words, the quality was less. So, I mean, you've got information. You knew the rock was bad a long time ago. It can't have been a surprise. You look at it, your permeabilities were high, your velocities were low, and you had bad core recovery. It can't have been that much of a surprise that you're dealing with bad foundation and bad rock recovery. Surely.
Well, the foundation of the dam has matched those expectations, and that's why I'm saying that has been excavated just about exactly where it was expected to be. It's the quality of that rock material for building the dam with, which is coming off the hillside. So the trials that were being relied on was where they excavated and built these pads, and as Mike said, those went reasonably well. And a lot of decisions seem to have been made on the basis of those. What has happened and that is that they've had to take a lot of this overburden off, which is the soil that was always expected to be removed, and then they're down to the actual material to build the dam, and that all the only precursory information, investigative information you had for that was these holes and what could be extracted from there. So they have, and when they're excavated, it looks okay. By the time it's put down with big machinery and rolled with big machinery, it's starting to break down, and it ends up like one of those photos. So it's the mechanical action that's making it difficult. The mechanical action of the machinery.
Yeah, but if it's crap rock, it's going to happen, isn't it? If you've got decent rock, it's not going to happen if you've got crap rock. So the investigation wasn't extensive enough for what you're trying to build there. Obvious. Come on.
Yeah, I mean, if we'd given more money, we would have done more exploration. Yep. But no, seriously, right? I mean, the exploration is not cheap.
I can't believe that just came out of your mouth.
So
you want more money?
No. This is before, right? This is.
You haven't got a price to the steel.
So before the project was funded, right?
You haven't got rock there you can use.
Exploration was done on a very finite budget, right? And you can never do enough exploration. We could have put 40 bores in there. Maybe we would have picked it up. Right.
It would have been better putting some weirs in the river and just let the river build up its own natural dam.
So what would the cost of putting 40 holes down? I bet it wasn't 29 million.
I don't know. So let's be clear here. Okay, maybe in hindsight, and hindsight's a wonderful management tool. Yeah, you would have picked it up. But the design done by the design done by the designer did not accommodate this material, right? So the design that was done did not foresee this, and that's the design that we're working with. And so, you know, look,
Time to stop it then if you've
Nah.
got major issues with it.
sorry?
Time to stop it if you've got major
Well, I'm going to
issues
show you
with
some photos in a second, and it will cost you more to stop than finish. Right?
Never.
it.
Sorry?
Never. No,
Never.
Tonkin and Taylor put caveats in numerous reports, and that their reports on the quality of the rock always contained a caveat. Hopefully, maybe, perhaps, that sort of nature. And this is why it's bounced back onto you from the council, from Bush King and Drummond and Kirby, that they're trying now to say they obviously relied upon experts and so on and so forth. I appreciate the difficulty of that, but at the same time, come on now and say, you know, we found all these difficulties. It doesn't really wash, because they were there to be seen. And understandably, your difficulties will occur.
Yep.
But this is a huge burden on people, and it's very, very worrying for people who actually got to end up paying for it.
Yeah. Look, I
Be accountable for spending other people's money,
I get it, right?
rather than talking about hindsight.
So we've got a design that Tonkin Taylor did. It did not foresee this. It did not have a continuous drainage layer. We have discovered material. So, and this is just a small part of the drainage layer. 3/4 of the embankment is not impacted, right? So we're adjusting the drainage layers for the conditions. And the first thing they teach you at dam engineering school is adapt to the conditions, right? So those of you who've been to engineering school know that. So you adapt to what you get, and that's what we've done. And I shouldn't have to apologise to make a dam safe, right? So that's what we're doing.
Actually, what they do say is you do your exploration first, and then you adapt.
And
Well,
then make a decision on what you're going to do.
And you
about it.
don't,
You got it back to front, mate.
you don't put P95 halfway through.
Sorry, Richard, just settle down a wee bit at the back. We want to answer the questions, okay? So just one at a time, and just ask sensible questions, please.
Right.
We
Is there
can't
any
turn
indication
back
on that
the years.
picture there to
Right, let's-
indicate
So- sorry,
where this rock's
Sorry. No, we'll take
Okay.
one question at a time, and if you put your hand up, we'll take one question at a time until they're all done. Sir.
Right, just a couple of things. Is there any indication you can point to here on this picture where the rock is coming from that you've got a problem with? The reason I say that, I've trucked quite a bit over the last 20 years on my farm roads, and I run into problems with rock from this neck of the woods all the time. It crumbles, it deteriorates, and the minute we had a contractor come in about a year ago and use a roller on the roads and that, and it literally just crumbled into powder within no time at all. You know, it was about a 10-ton roller, and it just literally disappeared.
Yeah, and that's what we're seeing with the
You know,
Argent.
and it was about $35,000 worth, and it just went.
So you asked the question, where's it coming from? This
Yep.
is the spillway cut. This has all been cut, right? This
Yep.
bridge has been cut away. It's all coming from down here.
Yeah.
So you can see it's been cut back.
So it's very similar to the other quarry sites around this neck of the woods.
No, in fact, the quarry down the road, just down, about 6 k's down the road, is
Yep.
Taylor's quarry, and it's very different.
Different again.
That's
righto.
that's where we're getting the rock from. That's where we're going to buy the rock from, because there's actually much more sandstone
Okay.
and harder rocks.
So any indication of how much stronger that rock is? Have you measured the strength of it compared with what you've already got?
So before there was 2 photos of broken down rock on the right, and there was really good quality rock on the left.
Yeah.
Sorry,
One
keep
more.
going back.
One more.
Yeah, that's from that quarry.
Yep. And yours is?
So the one on the right comes from the site.
Yeah.
This one comes from the quarry.
Right. Is that the one you were going to use?
So this was a test.
That's a bit like your stuff you saw in your roading,
Yeah.
where the 10-ton roller smashed
Yeah.
it. This one here has been rolled by a 10-ton roller, and
Yeah.
it's like this.
And it's still staying like that,
Yeah.
right?
That's what you planned originally to use, wasn't it?
So
No.
this,
Before you had to buy it from Taylor's.
No, he was using something else. Where's the stuff you were using originally?
so
That's it there.
That's it there. Yeah.
Jesus, mate, I wouldn't have even thought about it.
So what we're seeing. Just go back to the next previous slide.
Seriously, I'm not trying to be funny. If that's a sample of what you're going to use.
Go back one there. Go forward. So that one there. So we can still use that photo you saw on the right, where you just said don't use it. We can still use that in here, right?
Yeah.
So the logic is we put good free draining material here,
Yeah.
so we can, in the bulk of the dam, we can still use the other stuff.
Will it subside over time?
So it will settle as we build the dam, right?
Mm.
That's planned, right, Peter?
Yeah.
Mm.
But
It does seem-
the theory is we can use the indigenous rock in the bulk of the dam here still, right? So by importing some drainage rock, we can still use what's on site for the bulk of the dam.
For the filler?
Yeah.
You're going to compact that?
Yeah, it all gets compacted. Yeah.
I'd still be a bit nervous about that, I'll tell you. What about volume of water in that rock? Would it start over time ooze back?
Well, that's what the drainage layers are for. And so,
Mm.
the Peter's guys have done the calculations about the idea is if the concrete face
Yeah,
was...
no, I was talking about oozing this way, outwards.
So the
While it's dry, well, without being completely saturated, it will
Yeah.
stay where it is.
Yeah,
So,
because once you get
this
that
is-
weight in behind of the water, and that
oh
soft,
no, it's good enough for that.
and that softer rock on the
Yep.
outside.
No, it's fine for that sort of scenario
Mm.
because it's got this drainage layer.
Mm.
Right, we had Richard, gentleman in the corner.
Yeah, have you pretty much sort of sourced how much extra rock you need now? Or are we likely to hear we're gonna need more?
No, so we have a pretty good estimate as to what we require, and we've procured it. We actually haven't trucked it into site yet, all of it.
So you're confident now that you essentially have materials on site to finish the project up?
So we have what we call a conservative case where we say we have to import this, right? What we're now trying to do is bring that cost down by using more material from on site. So what we are seeing is pockets of sandstone. We think, great, we can use this. So we salvage it, and Jim's guys, process it and put it aside, so it's a little bit less we can bring in, right? We're looking to see if we can get any more out of the river gravels, for example, to help bring that cost down as well. So we have a defendable basis right now, and the idea now is how much more can we get on site to try and reduce that cost.
I might have missed it, but
Sorry,
have you got some sort of filter
Excuse
going
me,
down the side?
excuse me, this guy
You got a
here.
cubic metre sort of number in mind of how much you need to actually truck in?
So at the
Or
moment,
the estimate, I mean, that you sort of estimated,
yeah, so at the moment it's about 100,000 cubes.
100,000 cubic metres.
So it's about a quarter, and we're trying to bring that volume down.
How many truckloads is that?
Yeah, my question follows on from that, and it's this, that resource consent was given for a concrete face rock dam with a free draining structure like we see there, with the rock sourced on site, and a concrete face, and you'll presumably come on to the PVC aspect in a while, but for the moment, I'm concerned about the move from a free draining design in bulk to a non-free draining design, and also the importation of drainage layers from probably Taylor's Quarry down the road, and whether in fact, if it's going to be 100,000 cubic metres of rock that you're going to bring in, is eroding going to stand up to it? I'm no trucker, but if it's going to be 10 tonnes a time, I mean, there's a heck of a lot of lorry loads of rock to take up there, which should be on site, but obviously isn't. And the joinder to that question is, some of your work is going to need to be concrete. Are you going to be able to find the hardcore for that on site, or is that hardcore and that concrete material going to be brought in as well?
So,
Can you speak up because it's very difficult to hear.
so your second question first. So the aggregate for the concrete is always going to be imported, right? And that's for quality control, right, Jim?
Yes.
Your first question regarding the roads, yeah, we are conscious of the roads, and part of the cost that we've described includes managing those roads, right? So some work on the roads. What we are doing is, the sooner we get started, and we have already started and brought in the first, 10 or 20,000 cubic metres, is we can do it, reasonably slowly. We don't have to bring in, a huge number of trucks each day.
Sorry, who was next? Did you want to ask your question now?
You might have talked about it before I came here, but is that a sort of a filament on the inside of the dam there? You here.
Yeah, so there's actually a number of zones in the dam,
Yeah.
and they have different duties. Do you want to talk about the zones, Peter?
Sure. Okay.
The 2B.
So there's the face on the dam,
Yeah.
concrete face or the PVC, but behind that is a zone, the one without the big circles on it.
Yep.
So that is a gravel, and its job is to restrict the flow if ever this was to have a leak.
Yeah.
So its deliberate intent is that's its absolute number one function. The zone behind here drains any water that gets through that.
Because the reason I'm getting into that, we're talking about the rock we looked on the left-hand side that's going to be in where your circles are. Is that correct?
This, yes,
Yeah.
yeah.
Because that rock, it splits in very sort of slithers, if you like, almost like adzes, when you have it on the road, and it goes through car tyres, truck tyres. And if it's there, and you've got an earthquake, and it goes up and down like this, it will cut anything in front of it.
So the rock you described as being sharp and
Yeah.
so on is the rock that's going in here.
Okay.
So that's the mudstone and
Yeah.
the stuff that.
But
when
that
it's-
hard blue rock that we saw on the left-hand side,
Yeah.
that when that
That's-
breaks, it turns into very sharp pieces.
It's not too bad for that.
Okay.
We've looked into the sort of angularity or
Yeah.
sharpness, whatever you want to call
Yeah.
it. So that's not actually too bad
Okay.
for that. And this material here comes from the riverbed, so it's the rounded gravels in the riverbed.
How thick's that layer?
This one here,
Yeah.
it's about 2 metres thick.
2 minutes. All right.
So
Questions?
Let's go to
Oh, yeah, sure.
Yeah, if I could come back to your slides earlier on regarding costings and the cost of COVID-19. A figure has been mentioned of something of the order of 13 million, and one of the things I think you said was that could include some employing some tradies who might be unemployed because of the effects of COVID-19. But still, that won't be all of 13 million, but I'd be interested to know where that 13 million, how it tots up. And I would like to know that in the light of the fact that the COVID-19 payments that were paid out by the government to tailors amounted to, the tailors construction amounted to over $150,000, and to Fulton Hogan over about $3.5 million. So it's not as if those two companies should be really coming to Waimea Water, I would imagine, for some sort of funding to help them over the period. So could you explain what it is that's made up of?
It's made up of sort of two parts really. The first part is the cost of the suspension.
Sorry, could you speak? I really can't hear you.
Sorry, the cost of the suspension, and then the cost of the recovery, right? So that was the number that the TDC derived. With respect to the payments to the contractor, there's much more cost than the $585 a week, whatever the government gave. But suffice to say, the liability for costs between contractor and principal, and who indemnifies who, is a national issue, right? So the whole industry, NZTA, all the contractors in New Zealand are trying to figure out how to resolve this. It's going to take some time. Clearly, parties are going to incur costs. There's a lot more cost to site than simply $585 per person of wages, and so there is a lot of work to go yet.
It's going to be added to the dam as well.
Yeah.
Down the back.
Can you go back to your hydro?
Sure.
Back to what, sorry?
Hydro.
Oh, yeah.
Do you happen to have, a couple of a hydrograph that shows what your sort of expectation of flows are with the hydro project in place versus without hydro? In other words, what are you going to do to the flows essentially? You're going to put a surcharge on the dam. basically for hydro. So what does that do to your outflows?
So
you can't run a hydro plant on and off. It's got to be a continuous thing.
Yeah, no, it doesn't have to be continuous.
Well,
No.
to be efficient, it does.
No, it doesn't. So in fact, peaking plants don't run 24/7. So in fact, what the generators are really interested in is peak demand. So where they're very vulnerable is in an 8-hour period around early evening, I guess, where the maximum demand is. And the interest is in, can we use hydro for an 8-hour period? So can we store water for the other 14 hours, 16 hours, and then use it just over an 8-hour period? And that's where the interest is, and that's where this is actually a pretty good fit.
So then you're going to have load following essentially down the river. Have you looked at the impacts of that?
Yep, we have. And so
What's the outcome?
it actually moderates it. So at the moment, 80%. No, sorry. Let me get this right. 80%. 80% of the water goes down the spillway, right? And it goes down. It just follows the river flow. So when it rains, it goes from 2 to 100 cubics. What we'll do is we'll be moderating that and capturing that, so it's fluctuating less than the 2 to 100. So we'll be capturing that hydrograph within that storage area. And so, in fact, if we do use hydro, it would end up with less than 10% going down the spillway and the water going through the turbines instead.
Yeah, but aren't you going, if you're just going to be following peak power, then you're going to be basically ramping up and ramping down to meet demand. And so you're going to have a ramp effect downriver. And
Yeah.
you looked at the impacts of that.
Yes, we have. Yeah. I mean, at the moment, the ramp effect goes from from half a cubic, which is what we had sort of during summer, to 140 cubics. So we got a large range right now. Hydro will work between sort of half a cubic, the same half a cubic, and probably 9 cubics. So,
But that's not going to happen every day. I mean, if you're load following to try and pick up a peak, etc., then you're going to increase the frequency of your swings.
Yeah.
And that's generally shown to be environmentally deleterious.
no, we're looking into that.
Okay.
Look, at the end of the day, we're trying to create value, right? We're trying to get some more money in to help pay the project.
Yeah.
So,
Well, this infrastructure here you're going to put on top for the to give you more capacity for your water, for your hydro.
Yep.
You're not going to have the infrastructure on the existing dam to site that on top of it, are you?
so this would go where the OG weir goes.
With what?
So the OG weir.
Yeah.
So
Show me on the plan so I can see what you're talking about.
let's go forward one. No, go back a couple. Sorry. So there's an OG. Sorry. There's an OG weir across here, which is I don't know 2.5 metres high or something.
That's where this.
And this will basically be replaced by what you saw in those last photos. This spillway and the reservoir is designed for a maximum probable flood, I think, of about 1,100 cubics.
So you're going to hold the water back from going down the spillways. How are you going to do it?
So the spillway is designed for 1,100 cubics, 1,100 cubics, which is called the probable maximum flood, right? Which actually never happens. It's almost infinite. I think from memory it's about 3 times the 1 in a 100-year flood, right? So it's a very, very rare event. And if you go back to the other, so there's a huge amount of catchment area, and spillways designed for something that probably will never happen. And what these fuse gates are designed to do is use that storage and basically trip at a much lower level, so that you could actually trip them at a 1 in 10,000 year flood, which is 1 in 10,000 year flood would be around about 50 to 70% of the maximum
So with that
flood.
structure in that spillway, how much higher is the dam in relation to that? Is it going to be able to go over the top of that before it breaches the dam? If that fails and they can't...
Yeah, that's the idea. Yeah.
Yes, there's a wall on the top of the dam,
Yeah.
which is higher than any of that stuff.
How much higher?
About 3 metres.
How much?
3 to 4 metres higher than that stuff.
Sorry, you had a question.
COVID-19, you've got to admit this is financially, this is a bit of a disaster on the TDC. We've got the port and we've got the airport shut down, and the TDC must be putting some figures together now of the impact at the present time without having another shutdown for the virus taking off again. What about the possibility of mothballing it and coming back when the TDC is a bit stronger in 4 or 5 years' time?
Well, it would be one hell of a financial cost. Let's just go to construction. I think it's worth showing you where we're at construction-wise, because when you see how much has been built, you know, to leave a dam half finished and pay the contractor out or tell them to go and, you know, suspend works is one hell of a cost, right? And then you need to come back and reconvene later. If you see what we actually built here, you'll realise that, you know,
there must be a limit though to what the TDC can stand in the way of debt between this and COVID-19, especially if things went wrong. And I'm aware now that there's a lot of people who are going to have problems paying their rates and things like that. And this is early days, when the subsidies come off and everything, and we've got the raw reality of the situation to look at. And, you know, and like in the TDC there today, you know, 5,000 unemployed in the Tasman area. You know, that's their prediction here in the booklet produced today. So they're talking 10% of the population. That's an enormous burden on the community, and then to have this on top. And I know for myself, you know, I've got quite a few properties, and the rate demands at the moment are pretty enormous, you know, and to have the burden of everything else, and I'm subsidising leases, 50% and a whole lot of things. So, yeah, it's a big ask.
Yeah, look, I don't think anyone saw COVID-19 coming. So,
but we've got it here. And like everything's in life, you've got to deal with it up front. And
correct,
this here is a massive Rolls Royce you're looking at.
No, I get it, right? But what I would say is that New Zealand's economy is going to be hit pretty hard. Tourism's gone for quite a while. What we need to rely on now, as a ratepayer and as a Joe public looking at what's going on, is what's really saving our ass right now is our primary industry, right? So, you know, we're seeing agriculture, horticulture will still keep going. They haven't been impacted like tourism has. And this helps those industries,
yeah, but
right?
on average, it doesn't really affect Joe Blob, you know, and the rental flats just down the road here or anything like that.
Sorry guys, oi, sorry, we just want to have a sensible
discussion. It affects more
discussion.
a handful of people at the top who are going to make fairly large sums of money, and I know quite a few of them in Motueka.
But don't we
The Joe
eat
Blob
their
community
vegetables?
is not going to be rewarded at all.
So
All that's going to happen is rents are going to go up.
So the cost of the last year's drought in the economy is $50 million.
Yeah.
That was people out of jobs, not working, not spending money in cafes, that sort of stuff, right? So what this does is it helps our resilience to those sort of $50 million drought hits, right? So it is $50 million was the estimate of the hit. People lost their jobs during that drought. People didn't buy tractors or machinery or software.
The drought impact is not only great
Sorry,
for Nelson.
So, you've had a good go, okay?
Yeah, okay.
You've had a good go.
Right, you're telling us the rest of the community is going to gain from this. Where's the pipelines going out of this supplying water? Where's the reticulation system out of this supplying water? It's not going to supply to any town where these ratepayers are living, is it?
It's a natural pipeline. It's the river and the aquifer, right? And this is the beauty of the system.
So with a pipeline, you could cut the dam down half the size because you wouldn't have to pour the water into the river to pump it back out into a pumping system, because you'd actually flow it out of a storage area.
Well, so
you could keep a fair bit of water flowing out of the dam naturally and have enough held back there for your reticulation and run through a piping system.
Sorry, the system has been proved, so we're not going to go through that. We're trying to give you an update.
Well, if you're not going to build a big dam, you're going to have to build something smaller, and you need to go back to a reticulation system.
No, we're not doing that, because a third of the flow is for environmental flows. So just sorry, it is. Don't.
Hang on.
We're trying to give you the facts here so people can make their own decisions at the end of the day, but we're trying to give you an information evening and an update of where the dam is at. We're not going to relitigate the dam in the first place, okay?
So the Ministry of the Environment's providing money to the dam, right? In fact, it's TDC equity. They're giving money to TDC, a grant, free money. Here's the money. It's now going to be TDC equity, and that is for environmental flows, right? So the central government is giving us money, or giving TDC money, for the benefit of environmental flows in the river.
And at the same time, my tenant's rent goes up because I've got to pay more in rates.
Sorry.
Game, set and match.
You were just telling us that it's a proven system, the
Yes.
reticulation. I've only been here 15 years. I've never seen that river dry up. Now, if the theory, which I've been told, is you increase the flow, or if there's water in the river, it's going to sink down. I've never seen the water of that creek run dry yet. So,
Well, that's
I
probably
would
the last
imagine
thing we
that-
want to do, and this will prevent it doing that, okay?
I-
And it has gone dry.
It flows down
It has gone dry, and there'll be a number of people in the room who will verify that, and it should never go dry again, and this will prevent that.
last summer was when we, they were all cracking the whip, it's going to do this, that, and the other thing. There was still water in there. Now, if your theory is if there's water running down the river, it's going to go down through the filtration system
Correct.
and fill the aquifilter or whatever it is up. Well, there should be no water running through there down the river when we're dry. It should have all gone down.
We're not allowed to run the river dry, and all irrigators and producers, and I'm one of them, were rationed. That's what happened, and the river is not allowed by government regulation to go dry anymore. 2 reasons. If it went dry, we get saltwater infusion and TGC wells are in trouble.
Yeah, I understand that.
Okay, can we move on?
Okay, so let's talk about where we're at with construction, because we actually have achieved a lot. So the culvert is the main vehicle for, well, it's where we divert the water through so we can build a dam. That's this concrete structure in the middle here. That's coming up 80% complete. It's a very, very decent concrete structure, 160 metres long, and that's due to be complete in a few months, and we'll come back to that. This on the left-hand side is a left-hand plinth, so you can see the plinth's being formed down here. And if you look carefully, you can see that the anchors have been drilled in here, so they've drilled the anchors. On the right-hand side, you can see the plinth at the far side there, underneath the stabilised area, the bank that's been cut back, and you can see the spillway cut happening down here. This green line basically shows the future crest of the dam. So the left-hand plinth, the culvert, very well progressed. The right-hand plinth's sort of moving pretty fast now, and we're into that spillway cut. So if you go to the next slide.
So all that pipework's going through this tunnel, is it?
Yeah, so here, yep. So this is the culvert being constructed now. So you can see here sections of this walls are 1.6 metre thick concrete. It's a decent structure, and so you can see this is looking down the culvert. We have the floor is now finished. 12 out of the 17 wall and roof sections are finished, and we expect to actually have this finished by August. So ready for the river to go into in September. Here's another photo of the culvert.
So is that where the pipework's going inside that?
So what happens with this diversion, this culvert, is while the dam gets built above it,
Yeah.
right? So the river's going to flow through it,
Yeah.
right? So the river flows through it,
Yeah.
and then when the dam's built, we then seal it up and we put the pipework through it. So then the pipework then runs through that. And that was that 3D model you saw before, the
Right.
pipework coming through it.
So that's got to be costed in to install it inside there?
That's the plan. Yeah.
Okay.
So if you look at the left hand. So if you look at the left-hand side, so you can see here the plinth is being formed up now, and this is really the toe of the dam. Peter alluded to this before. So this is the toe of the dam, and it's anchored into the rock. So you can see the anchors here, anchored into the rock. It's they then drill the grout curtain through this. So that's the cement curtain that goes beneath the ground. How deep is that?
Up to 30 metres.
Yeah, so we go down 30 metres for the grout curtain. It seals into this seals into the face of the dam. So basically you've got 50 metres above here, 30 metres below ground, all being sealed and held together along this plinth line here. So you can see here they're drilling those anchors. And on the right hand side is the formwork that's been used to basically to pour this concrete plinth. On the right hand side, Jim's guys are busy preparing the plinth right now. So they've poured a little bit at the top here. This is gentle treatment, so as we clear the foundation rock, clean out the crap, and then fill it, put fillings in effectively into the rock, and then we'll be close to pouring concrete down the right hand side as well. With the spillway, so as Ian said before, the spillway cuts well in progress here. That's the cut being coming through here. This is the side of the spillway. You can see here that they're busy clearing this piece of foundation. So we're not too far away from actually inspecting and preparing the foundation for the first part of the spillway. But we do have the geological challenges you'd expect. One of them is voids. So you can see here we get these holes of sort of soft rock that have to come out. It's in front of the culvert. It's down upstream from the culvert. These need to come out and be filled with mass concrete. So we've used about 1,000 cubic metres of mass concrete so far, filling these holes up. Here's a classic example. You can see we've got some rotten rock through here. We've had to pull this out and then basically pour rock through here, pour concrete through here, and then basically replicate the rock.
But this is going to happen where the water is going to be stored, isn't it? It's going to build pressure up under all this sort of structure and start working away.
So this here is the plinth. This is the plinth. So the plinth comes through here, and it gets anchored through this, and then the grout curtain goes 30 metres below down here to seal it all up.
No, I'm talking where your lake is. It's going to be happening on your lake, isn't it?
Yeah, so the lake's upstream here. That's right.
So this sort of effect is going to be happening under the lake. You're not going to be able to control it, are you? You're going to have the same problem that they had at Clyde, and they had to pour so much concrete at Clyde, it was unbelievable. It was 10 times the cost of building the Clyde Dam, just to hold the structure and the hills around them.
No, talk to Clyde, I don't know.
This is a big big topic in itself, Clyde.
It's the same thing, just on a bigger scale.
No, well, the Clyde issues you're talking about were big landslides, huge landslides on the hills around it. The dam itself, fundamentally the same sort of thing was going on. They excavate the rock, anything that wasn't suitable was thrown away and then replaced with the concrete. Much the same as
well. Concrete dam, with a weak design.
Yeah, that is correct. Yeah.
So you're telling us you're not going to have any slips in the hills above this water?
That's part of the investigation program. Was to identify any of those, and we're actually reviewing that right now to make sure there's no surprises. So that's no, it's different countryside. I think we should point out as well that the Clyde Dam rock has a very ancient landslide features. It's quite a different rock. This sort of rock is
more solid.
Well, it's the hillsides don't have that same incredibly large landslide problems that they do in Clyde.
Well, they didn't think they were going to get it neither when they designed it originally.
Is your grout curtain going sideways as well as down, or is it just going down?
It goes all the way from one end, from the top all the way around, and the holes are being angled so that it connects to all of the features in the rock.
Yeah, but from the ends of the plinths, is it going back out into the hill, or is it just going?
It's pretty much vertical below.
So any cavities on the or any fractures on the within 30 metres of the end of on the plinths isn't going to be picked up.
Well, the idea is it's forming a curtain, as the name applies, so that if there's cavities underneath the lake, that cavity can't pass through there and then pass out the bottom.
It can pass out the sides too, just as easily, can't it? That's what I'm trying to get at. Is there a curtain going out the side, or is it just going straight down?
Well, it heads all the way up the hill and across the road at each end, so it is extending further out than just where the dam is.
Sure. Won't happen up the valley any further.
Just a minute, sir.
Why we got this slide up of the showing water, one of the questions I've heard often is, or points made often, is that the reservoir is unlikely to actually hold water because the Bryant ranges are so fissured with splits and cracks and what have you, that it's unlikely that the dam will actually fill. What's the case behind that? Is there any truth in it, or what's going to happen?
I have no idea what the case behind that is, but that is why we had the grout curtain. right? So the grout curtain seals up 30 metres down, right? And right the whole way around the front of the dam. And that's exactly why we're forming this grout curtain, to seal it up.
That's around the dam, isn't it?
Sorry?
That's the dam.
Yeah.
What about the reservoir foot, the actual, the area of land underneath water at the end of the day? Is that water going to stay there, or is it going to drain away as part of the groundwater through the rocks?
So the modelling says it won't drain away. That's why the dam's been built here.
That's what aquifers are. They drain away under the ground. What nature does, and very good at it.
Do you have a question?
I'm just adding to it.
Okay, thank you.
What's the static pressure, water pressure at the dam face?
Well, it's 50
When it's full?
50 metres high. So it's 50 metres ahead.
50 metres.
Yeah, so if you crunch that through Darcy's law, I mean...
Is that a vertical height?
How many million litres in?
What, sorry?
How many million litres are we going to have in that tank?
So it's 13 million cubic metres.
13 million.
Sorry, we're still trying to answer your questions.
Yeah, you said it's 50 metres, the dam, but I want to know what the static pressure is at the bottom. Is that a vertical 50 metres or?
Yes.
Vertical. Thank you.
All right, finally, just get the next slide. So I just thought I'd wrap up, and then we'll go to questions. I recognise that this is a big project for the region, right? This is the first large dam to be built in New Zealand in 25 years. So in that time, New Zealand's population has grown by 60%, right? So we've not built any infrastructure for 25 years. The population's gone up by over 50%, 60%, and this is the first large dam. So I understand the angst, right? We're not used to building infrastructure. But look, it's worth touching on some of these numbers. We're excavating 633,000 cubic metres. We're putting 430,000 cubic metres into the dam. We had 22,000 cubic metres of concrete being poured. Almost 4,000 tons of reinforcing steel, and another 10,000 square metres of mesh, 4,200 anchors. The concrete face is 10,000 square metres, and all this for the price of 130 bungalows in Auckland. or 250 slides in front of Parliament.
So you guarantee us tonight that it's only going to cost 130 million to finish this project?
I don't care. I've been around enough projects to know.
That's what you're just saying. That's what it's going to cost.
No, that's not what I said. You're misquoting me. What I said is that is what we see right now, based on what we know now, right?
Plus the 13 million for the Culvert.
Yeah.
Yes. Yes.
Yeah,
Yes.
that's right. Yeah.
Thank you. You say at the bottom there, concrete face, and then you mentioned just now about this in wrapping up.
Yep.
You haven't mentioned the change from a concrete face to a PVC covering, which concerns a lot of people,
Yep.
and is away from the actual resource consented design. What's going to be happening with this? Has it been resolved yet? And is there any warranty added to the warranty which was originally advanced for about 10 years?
Are they going to use plastic?
Yeah.
Are they going to use plastic?
Are they going to
Use it? Are they going to?
Yeah, are you going to use it? Yeah.
So right now, the plan is a concrete face. Right? We have looked at options to try and reduce the cost, because I can hear you guys talking about cost a lot. Options to reduce cost. We are still evaluating it. We're still working through the evaluation process. It's a very tried and true product that's been used on hundreds of dams around the world. It's a very resilient product. The expected life is well over 70 years. But we still have not finished the analysis, and we need to actually understand the benefits before we change. But right now, it's still a concrete face.
So do you see the danger in what you're all doing? That the cost has gone from something mentioned, the P95 evaluation of 90% assuredness of the cost coming in at 60 odd million, and then up to 80 something, and then 102, and now we're at 130 24 plus the 13 or whatever, is that something which is justifiable now, bearing in mind that you're going to push into the future with an unknowing situation and ratepayers footing the bill? And it's extremely concerning for those people who actually think about it, that it's gone from this up to that, and will it go even higher? And the answer is probably, we think yes. But what do you think?
Well, I think that in New Zealand's forgotten how to do infrastructure projects. I mean, we have over 100 large dams in New Zealand. You think about all the power projects and the Waitakaris and everything else. And this is the first. The Waitakaris are water. So this is the first large dam in 25 years. You know, the whole country is struggling. Look at Auckland right now. They could well, you know, they have massive water constraints. Northland are tied up water. The whole country is now.
I think we've got to separate things which are truth and spin. And I would suggest to you that the story that comes across, that the 2018-19 summer and the 2019-20 summer were droughts for which we should be grateful for the coming dam. I ask why, and maybe Mr. Rain could answer this, it's very much in his field. How come in that period, that awful, intense summer period of drought, the Waimea plain stayed verdant, whereas up on the foothills, where we are in Hope, it was as brown as could be. So I know Murray Dawson has been saying for some years that the water in the aquifers is sufficient to last probably 100 years. He said, that aside, the question remains, how come nobody has asked that very pertinent question? If we need this dam, and it's a wonderful construction, I grant you, and it's very clever, etc., etc., if there weren't so many problems with the costing and what have you. But if that is the case, that those paddocks on the Waimea plain remain so verdant, and there were bumper crops of pit fruit and vines that I can recall being spoken and others this year, how come we need such an expensive dam?
Do you want to talk about the damage to the droughts and also the mild water restrictions? Sure. So as a producer on the plains, and there's a number of them in the room here tonight.
Can you speak up, please?
As a producer on the Waimea plains, and there's a number of them in the room here tonight, if we don't have this dam, the whole of the Waimea plains will become a dust bowl. Rubbish. No, it's not rubbish, because you cannot grow crops. Because what has changed is the minimum flows in the Waimea River have increased. We've got more extremes now than what we've had before, and so you need a reliable source of water, not only to grow crops, but also for commercial activities, whether it's here in Richmond, Brightwater or Mapua. You need commercial operators who can carry on operating, and whether it's the freezing works, the juice factory, the cool stores, you need reliable water for them. It's not all about irrigators, it's about the whole community, and that's what this dam is. It's a community dam.
But your prospectus said that the take of the irrigators would be a minimum 70% of the water.
For a particular time,
yes, but it's only a particular time that the dam's going to be needed for, and it's in that high demand of high summer and drought. How come your Wye West and everything else was so beautifully green last year? And because you could pump water over it.
Well, we can pump some water over it, but we don't pump.
You could pump enough because it was green. It wasn't going dry. You weren't losing. You weren't losing.
Well, sorry, but we might agree to disagree on this.
And we did get saltwater inundation during that drought. And we were close to having our taps in town turned off as well.
So, sorry, we'll take this gentleman here and then I'll come to you.
As this is so expensive, the ratepayers simply cannot afford this, and it's going to go on and on. I know it's going to get higher. Why don't you get the government to come in and do it. Because if this is such a major project for the area, for the growth of the area or whatever, as you say, get the government to pay 50% of it.
They have already.
But that doesn't, only, it's not a straightforward money. But we are in the zone of benefit, but we don't have any water. Our water comes off our roof. And yet we are going to have our water rates done on our what's the word called? Capital value. Now that is not fair. That is not Colin and I working on it.
I'm not the TDC, so I can't answer those questions.
No, I know you can't, but this is where all the efforts should be made, is to make the government pay.
So, and I'm not going to speak on behalf of TDC, but we know publicly they have applied for the government for
10
shovel
million only for the dam.
Sorry, I can't answer on behalf of TDC.
But can you use your influence?
Well, we've used as much as we can.
You've got a huge amount of influence.
So I'm going to ask this gentleman here the next question.
You won't answer my
Right.
question.
Well, no, he was, to be fair, he was next.
Supplementary.
We're not Parliament here, but we are going...
I'm an engineer, I'd like a bit of mechanical knowledge here. The pipe that's going to feed this water through this concrete structure you're building at the moment, what diameter of pipes are we talking about? And how many are there?
What have we got? So we've got 1.2 metre diameter pipes face the dam, and that feeds into a 1.4. It's like the Culvert, doesn't it?
Sorry?
Sorry, so there's a... we're looking upstream in this photo here. There's two 1.2 metre diameter pipes on the face, which we can't actually see. Then that feeds into this 1.4 metre diameter pipe through the culvert itself.
So, and this, have you got a ballpark figure for this? Because you haven't got a quote yet. What's the ballpark figure for this structure that's going inside that concrete?
It's commercially confidential.
Sorry?
It's commercially confidential.
No, the people here have got to pay for it. It's not confidential. It's not.
Two good words there.
Is that included in the $130 million cost to build this dam then?
Yes, so the cost of the pump falls here.
It is. You've costed it already? Yes. Okay. So you've got a ballpark figure of what it's going to cost. But at the moment you're telling us before, you're still waiting for estimates to come in to tell you how much it's going to cost. And they're still designing it with what you're saying.
So we have estimates already. That's what we used a quantity surveyor to help us come up with the price.
Okay.
And then we added some risk money on as well. Okay. Right. And now we're waiting to see what prices come back from suppliers, so we can see how that compares.
So not many blowouts. You're just going to go for the best price.
Yeah.
Cheapest.
Yeah. Okay. Good on you.
The
Okay.
rate,
So I can cross that one out.
the ratepayers of Tasman, can you tell me clearly what is the benefit of this dam for them?
well, there's been a number
Because they're paying for it, what is the
there's been a number of studies, and if you give me your address, we'll send you the studies.
You ought to be able to tell me right here and
Well,
now. What is the benefit to this district? What is the benefit of these people? Because at the end of the day, it doesn't provide...
Reliable water for a start.
From where?
From where? Out of the river? They're going to go down there and bucket it?
No, the TDC has a municipal system that's reticulated to the houses on the Waimea Plains, Richmond.
So they're going to pump it out of the river?
No, they've got bores already on the Waimea Plains.
Yeah.
And they fail?
So in terms of labour, it's not going to give them jobs because you import all the labour. So who else is
Well,
going to
we
benefit?
couldn't find any labour before because everyone was employed pre-COVID. So we need to...
Yeah, but you know as well as I do, you still require that overseas labour to make this whole thing go.
What about all the local industries that employ people picking fruit in the juice factory? The future of our children having jobs here, the future of our region. We
Juice
need the
factory's
dam.
been shut down. I used to work there. I used to help run the thing. Used to bugger all water.
So look, Julian's point is that there's a lot of reports on both the TDC and our own website as to the economic benefit of this dam. So I would look, it's done by independent economic experts. They publish
All
reports.
I know is the
Excuse me,
rentals.
sir. Excuse me, sir. He's trying to answer the question, so just give him the benefit of answering the question.
So look, I'd encourage you to go and read those reports. I mean, we can...
I could probably drown in them. I'm asking you, the benefit to the local people who every quarter are paying their rates and they get bigger and bigger. And my water rates get bigger and bigger, which I transfer onto other people. There's no benefit for the ratepayers of Richmond.
Oh, I think it's huge benefit. In fact,
Why? It's huge.
No, I would
Explain the figures to me.
So the benefit I'm enjoying right now is Collins vegetable place, right? So they opened up, they invested, and they built a retail outlet that you can buy vegetables at lower prices now than supermarkets, and they only invested because they knew the dam was going ahead, right? So the benefit to me, as a selfish ratepayer,
Most of the vegetables here get imported out of here to Auckland and the rest of the country.
So
I go out on trucks every day, I know.
I am enjoying to see people investing in the area, right? So what
The money from those...
cost veggies, right? So I'm happy with lower price food.
Sorry, Matt.
Yeah, Mike, just a question. With this PVC, have you come up with, are you going to use it yet, or are you still deciding?
Still deciding.
Okay, just one question on it. Does it, like, after the fires, is it actually a flammable material?
It has a fire retardant.
Good.
So it's been used in tunnels, for example. Right?
Okay, oh, that's perfect then. The other last question was, with the power plant you're looking to put on, is that looking to be run more as a private firm coming in to set that up, or is Waimea Water looking to run that?
So the actual power plant, no, Waimea Water Limited won't run it.
Right,
It's not our expertise.
So it'll be run by a separate company?
So for example, down at Opua Dam,
Yeah.
which is an irrigation dam in Canterbury, Trust Power run the turbines and sell the power and whatever else, right?
Good.
So
did Andrew have a question?
Oh, yeah. Look, I am one of the directors on the board, but I'm also a local contractor, so I have a bit of knowledge about contracting. Also a developer. You know, you want to know the benefits to Richmond? We couldn't work last year with no water. So there, you got 30 guys that couldn't build the roads, do construction, NPI. So it's not just about irrigators. And I've just written a cheque out today for 3.4 million to the TDC for our DC contributions. So that is why money is going to the TDC. If we can't get water, we can't keep working. So 100,000, and if you want to know what 100,000 cube is, that's what we imported to one subdivision. It's not a lot of gravel.
Yeah, well, if you take the pipes out of this and you shoot them into Richmond, might help your water problem.
Right.
I've got a question.
Sure.
What sort of earthquake will make this fail?
Good question, sir.
Same as the one last night.
Yeah.
Do you want to talk to the earthquake loads people?
At what level is it rated at?
Sorry?
At what level is it rated at?
So it's designed for what is described by the experts as maximum credible earthquake. The nearest fault rupturing, which is a Waimea West, I think it's called. It basically is about a magnitude 7.4 earthquake on that fault. About a magnitude 7.4 earthquake on that side, something like that.
Yeah.
I can't remember off the top of my head. So the dam has been analysed to be shaken by that level of earthquake, and it will, it will settle a little bit, but it will remain standing and perform its.
And how thick's the concrete face on it?
Concrete face is 300 millimetres, so it's about that thick.
You guarantee that won't crack?
I didn't say that.
I want you to guarantee it won't crack, because it will fail if it cracks under a 7.4 earthquake.
No, the dam will not.
The building in Wellington that was built to 120% of the building code is now a vacant section, and that was a Defence Force building built about 12 years ago.
So the principle of this, that if the slab is to crack, that the layers behind it will drain the water, and then the pipe underneath will allow you to lower the reservoir and fix any of those cracks.
And how many days is it going to take to fill this reservoir up before you start taking water out of it?
Well,
because you're not going to drain it out that quick, are you?
You're not going to drain it out with minutes, but
weeks and months.
Yeah.
It's going to take to fill this thing up.
So the principle is that during that period, if this had a leak, that during that period, a serious leak, that during that period, the water will drain through that drainage zone, like the gravel that we showed on that picture, and it will keep doing that until you've got that reservoir down.
You've got, what, 13 million tonnes of water behind this.
Yes.
So what's going to stop it from forcing a little bit of concrete out of its way? Not much at all, I don't think.
So the layers...
Once you start putting pressure on a broken structure, it gets bigger and bigger.
So
It doesn't take much of a hole to start it happening.
So the principle, the way the analysis of the design was we took the concrete face away and said how much water would be pushed through if that concrete face was missing. So that's that's way beyond the example you just talked about.
The concrete face is designed to hold the water back.
Yes. So we're saying
We don't want it to fail.
that we don't want it to fail,
No.
but if it cracks,
I mean fail, not crack, fail. If it cracks at that's 300 mils, it's not much concrete.
it's correct.
You've got that structure there at 1.5 metres thick. Why have you got that 1.5 metres thick when the main wall of the dam's only going to be 0.3?
The structure here.
Yeah.
This structure here has got the weight of the structure above it.
Well, isn't the face of the dam got the same sort of weight on it? It's 13 million tonnes of water behind it.
Yeah, and it's got a huge pile of rocks behind it holding it up.
Which is going to be shaken by a 7.4 earthquake,
Yeah.
like Kaikoura had. Kaikoura didn't know that was coming. Christchurch didn't know they had their earthquakes coming.
Yeah, I was there.
I lived on the west coast for 18 years. We're 300 years or 800 years overdue for a big earthquake in New Zealand. Bigger than 7.4.
So under the international and New Zealand dam guidelines, which is part of basically the engineers use under the regulations, the dam has to hold its contents and not release in an uncontrolled manner in a 1 in 10,000 year earthquake. Is that right?
1 in 10 what?
10,000. 10,000.
Yeah, earthquake.
Yeah.
Oh, what a joke.
No, that's
well,
how can you design something like that at 300 mils? That's not going to hold it.
No, so you're missing the point, sir. I don't know if you've studied dam engineering, but the 300 mil is not actually a structural member, it's a membrane. It's like a concrete in the swimming pool,
That's
right?
the seal that's holding the water back.
So what Peter said is that when they model it, they said, how bad could it possibly ever get? Let's just take the whole concrete face away. Pretend there's no concrete face.
Yep.
Take it away.
Yep.
And then they model 50 metres of head of water on a dam with no concrete face, right? And that's how you design the drainage layer. So without
that dam won't hold water like that because you've told us the rock you're going to use in the middle is going to break down anyhow.
No.
As soon as that gets water on it, it'll just wash away.
Sir, you're not listening to me.
Get a hose out on a pile of gravel and see what it does.
So what we're saying is that if there's no concrete face at all, right? Pretend this concrete face is gone, right? That 50 metres of water in the reservoir just sitting on the dam, it's designed to flow, so it flows through that drainage layer that Peter showed you before, right? That layer is designed to take the water with that head as if there was no concrete face.
So why are you putting a concrete face on then? You could save $100,000, millions of dollars by putting a concrete face on.
Because that's water flowing through the dam. The idea of the dam is to hold the water.
Well, you need it to get down the river, so just make the dam a bit more thicker. So.
I think we're getting to pointless material here.
Well, I'm just getting to the point
Is there any?
you're going to have
Well, no, sorry, sir. You need to understand a bit more about dam building. I don't, but there's some experts here who do. So you come back and talk to them. Is there any further questions?
Mike, can you tell us a bit more about the PVC, about the membrane?
Sure. So what do you want to know?
Well, how's it going to resist the UV, the New Zealand UV levels?
So it has a plasticizer in it, so it's being tested. They do accelerated UV light testing. The oldest dam is 1977, and that's in the Swiss Alps, and they empty it. Half the year it's empty. It just sits under lights. So. Whereas our dam actually sits under water most of the time, right? So the UV light is not anywhere near what you'd see in this dam. Anyway, over 50 years, I think they measured a 12% degradation in the material.
But you can't use Europe as an example because, first of all, it has an inversion layer that is miles thick. We don't have that, and we have a hole in the ozone layer that they don't have. So that's what you've got to think about first.
Yeah.
Where else has this PVC been used in New Zealand?
Tekapo.
Tekapo, yes, and that's 3 kilometres of race correct? Water Russ.
No, it's about 12 kilometres of installation.
12, is it?
Yep.
I was told it was 3. What's covering the PVC on that Water Russ? That
Oh, they put stones on that. That's part of the design for the canal flowing with the water.
Yeah.
So
They put
it's-
gravel over the top of it,
Yeah.
correct?
Yeah.
Yes. So it's not seeing the UV light.
And most of the time our dam won't see the UV light either because it's underwater.
So also,
But it sounds to me a bit airy-fairy to say most of the time. What happens if it leaks? What's going to happen in 10 years' time when suddenly the guarantee runs out and the company that's responsible for maintenance on this dam is then going to have to review what the PVC layer is like and whether it needs to be fixed. Because the PVC layer on this dam is not going to be covered with gravel. It's going to be open to the light. So if the water level goes down in the summertime, which is when you say you're going to use all the water, then that's exposed is going to degrade.
Yeah. So you raise a valid point, sir, and the science and the laboratory testing is looking into that, and that would all be part of the design report. Under the building code, under the building regulations, we have to demonstrate longevity. So it will be considered. And to answer your first question, this membrane is used in quite a few dams in Australia too.
How thick is this membrane?
Oh no, there's 3 or 4
Sorry, sir.
Yeah. Sorry, how thick?
Sorry, sir. No,
I just want to know how thick the membrane was, sorry.
so just
about 3 mil, I think.
I still didn't hear you.
3 mil.
3 mil.
Only 3 mil?
Oh.
God,
yes, I'm trying to get
The
some.
phthalates in the PVC membrane. Phthalates are put in the PVC membrane, I understand, in order to make it pliable and bendy, so it can be applied to a dam wall. Phthalates have been criticised by, I think, World Health Organization, and they've been banned in baby toys, where babies can suck them, for some time now. It concerns me and others that the phthalates in the PVC membrane might leach out into the water, and probably will, and represent a danger to aquatic life and possibly humans. And I wouldn't really fancy it in my coffee, I don't think.
So are you concerned about the lower molecular weight phthalates or the high molecular?
Am I concerned about
the lower molecular weight phthalates or the high molecular weight?
I'm concerned about the existence of phthalates in the PVC membrane, which are included in order to make it pliable.
So do you understand, sir, the difference between the lower molecular weight phthalates and the high molecular weight?
I'm not sure that I do, but the point is, can you answer the question? Does
Okay.
the product
So you're right.
referring to-
So you're right. So some lower molecular weight phthalates have been banned in Europe, right? That you're correct. They are the lower molecular weight ones. The higher molecular weight, which have more than six carbons in it, have not been banned. They've been verified as being safe by the EU, whatever they call themselves. The EU chemical safety.
You're saying that there are phthalates which are safe.
Yeah,
and these are in the PVC.
Yes, correct.
That is used in the product you're
Yes, yes, sir. So they have a higher molecular weight with more carbons in it.
That's a relief, isn't it?
Yeah. In fact, they use the same product in like blood bags, for example. Blood bags.
Oh.
Bags.
Wow.
Sir, down the back.
If you are going to put the PVC liner in there, what are you going to have to bed it on?
It sits on the curbs. So the way that the embankment is constructed is basically a curb. I think it's 600 mil high.
Right, but are you going to be able to get away with gravel as the bedding material underneath it, or are you going to have to sand?
It sits on a stack of concrete curbs, right? So the way the dam is built, irrespective of whether it's a concrete face or a PVC face, is a stack of curbs. So each lift is a curb, like a roading curb, 400 mils, and then rock fill, right? And they compact that, and then they do the next curb, with a rock fill. So you end up with a stack of curbs, right? And the concrete face or the PVC lie against that stack of concrete curbs.
3 mil thick.
Well, there's a cushion layer.
You're not going to touch a hole in it.
There's a cushion layer.
Cushion layer.
3 mil is pretty thin.
What colour is it? The reason I ask that is because in using black plastic coverings on silage pits, they deteriorate quite rapidly as opposed to the toughened white ones.
That's true.
We get, 3 times the life out of it. So what colour is this one?
I think it's
White.
great.
It is white.
Look, sorry.
What's the cost of this PVC liner? Like, just so like in a maintenance sort of schedule, if something was to go wrong, how much would it cost us to replace that as a community?
Well, so one of the real benefits of it is really easy to fix. Like you can do patches, layers, whatever part you want, basically using a hairdryer.
You've got to drain the dam to do it.
Well, yeah. So you have to. I mean, it's any damage, whether it be concrete damage or the PVC, you'd probably want to drop the water. In fact, but this can be repaired underwater actually. So effectively, it's guys with a couple of hairdryers, welding a patch of PVC on the side of it. So, and just to finish the story, where concrete faces have failed around the world due to earthquakes, this carpy has been the go-to repair. That's how they go and then fix the concrete face, is that they actually just put a carpy with a PVC membrane across the top of it.
And do they have earthquakes like we have earthquakes?
Oh yeah, I think it's right. Bigger.
One of the highest earthquake-prone countries in the world, apart from Japan.
Yeah, so there's a dam in San Francisco right on the fault line.
Yeah.
It's about 100 metres high, twice as high as ours, and that uses the same material.
Can you just tell me how much it costs though, like the PVC liner?
So we will only go ahead with it. And so look, we haven't committed to it yet. We are working on the concrete face is the base case, right? We are looking at it as a means to save some money, right? If we don't get the savings out of it, or it doesn't give us the time benefit, then we probably won't go ahead with it, right? So we expect it to save close to $1 million if we go ahead. If we can't get the savings, we probably won't do it.
So you're not going to put the concrete there, you're going to put the membrane?
No, so at the moment we're doing concrete. So just to be clear.
And the membrane?
No.
Add-on to it. It's an add-on to it.
So at the moment we're committed to concrete,
yeah,
right? And we are evaluating whether this has benefit to us.
To put it on top of it?
No, concrete won't start.
No, instead of the concrete.
No,
instead of the concrete?
Yeah.
Instead of the concrete.
Oh, God.
Matt.
So then you go rely on the rock to hold the whole thing, no concrete face.
That's it.
3 mil membrane's not going to hold bugger all.
Sorry,
you got a balloon?
Yeah, Mike, just a question.
Expand.
With this pipe running underneath this dam, is it running it all the time? Or are you able to shut that off with this tunnel system you've got here? Just for, with maintenance, I just wonder if there's a suction down there for the likes of logs and things that were going to enter the site, upstream from the natives and possibly even harvesting. Is there a suction at that very bottom of that dam that can go through as well? Have you got some sort of a filter that stops the product going through, like whether it's wood or?
Yeah, good question, Matt. So let's go back to that slide of the 3D. So there's 2 intakes, Matt.
Yes.
So there's one down low and there's one sort of halfway up.
Yes.
So we can control temperature and oxygen levels, right? Each of those intakes has a screen, right? And I think the screen has a 20 mil gap. 20 mil gap in it.
Ah, yes.
Right. So nothing.
So like
bigger
a
than 20
native log, they don't float, but they don't sink.
Yeah. So
it's wonder when they come down.
So we have the screen at the intake with a 20 mil gap in it, right? So it's a 20 mil aperture.
Yes.
And then just upstream of that, we have a boom as well.
Ah, okay.
Right. So so the boom keeps the logs and debris away.
So something that's half sunk, like macro logs.
Yep.
Even though coming down the dam.
Yep.
Yeah, to the dam front. Is there a placement to catch them, or will they actually run up against that 20 mil piping, or mesh against the piping?
Yeah, so they could go up against the, and we design it so that they could go up against the mesh.
Ah, okay.
Right?
In a safe way.
And these intakes, these intake screens, they're 6 tonne each, right? They're not small things.
Yeah, no.
right? And so then the intake, keeps screens out any debris, and then the water that goes through the pipe then goes out through 3 valves. So we have 3 cone valves, so we can basically moderate the flow. So if you just did the small one in the middle there, that's half a cubic. That's the environmental flow, right? That's the minimum.
So someone couldn't actually be sucked in themselves while working down there, repairing these liners and things. I don't know anything about this one, Martin.
No, because there's a screen up. There's the screens at the intake, right?
Okay, that's good.
So we've got the gentleman in here first.
Coming back to the PVC liner. This has been said to be a 10 or 20 year warranty product for what has been sold to everybody as a 100-year dam. If it's only going to, and I've heard people say that, possibly even Waimea water, that it can last 70 years in Switzerland or something. But is that an appropriate finish, if you like, to the surface of the dam for what is promoted as a 100-year venture and possibility and benefit to the community?
Yeah, so the design life's greater than 70 years, and greater than, right? So they've said that 70 years is likely to be a minimum. It's designed. I mean, under the design codes, we have to design for the life of the dam, and that's what the design report addresses.
Sure.
I've got a couple of questions. The intake, the height of the bottom, so where the water's been taken out, and how much gravel is going to come in and come up to that level and end up failing this thing because you won't be able to get any water out of it ever again. What's the lifespan of that?
So the bottom intake is what's the RL at the bottom?
155 or something.
Is it 10, 15 metres at the bottom?
Yeah, it's a
So
fair way off the bottom.
So the bottom intake is 10 to 15 metres off the bottom.
10 or 15 metres.
Yeah,
Okay.
yeah. There's actually a dead volume in the reservoir, which is pretty standard for dams.
Yeah, so it's probably worth noting, Mike, that dead storage volume was a million cubic metres below that lower intake, and I predict there to be about 300,000 cubic metres of sediment over the 100-year life of the dam, which will settle in there. So there's a lot of buffer below that lower intake.
So I'd just like to switch now to people who have submitted questions who couldn't be here tonight. So I'd just like to switch now to those submitted questions. Mike?
So one gentleman, I think you've already asked this question, sir.
Yeah, no, I'm happy with that. Yeah.
Right, okay. Another question was interested in the funding, construction, management. I think we've talked about that. We talked a lot about the rock quality. I think the question was, would you agree that proper research of rock quality was not carried out prior to commencement? There have been rumours around the district that rock quality was not up to standard, which was disputed in the last meeting. The rock is not up to standard with respect to that drainage zones. The rest of it's fine. Maybe in hindsight, the previous designer should have picked it up. They didn't. I feel there's always, as I said before, there's always a balance between how much you're going to spend not knowing the dam goes ahead versus knowledge. And one of the troubles with trying to estimate the substrata is you've got a whole bunch of bores around the area, and it's essentially the estimates of the rock is almost on a linear extrapolation between those bores. And what we're actually seeing is the total opposite. We're seeing an absolute jumble of geology. 1 minute we're in argillite, the next minute we're into good sandstone, which is great. We get excited, and then we're back into argillite again. So it's very, very confused and complex geology.
Should never have been built.
Well,
Absolutely agree.
Look, I'm just representing 2 shareholders that committed to it, right? So, if you disagree with TDC's decision, you need to talk to them about it.
Yeah, I represent the ratepayers.
Yeah.
Has there been any modelling done on a total failure of the dam? What would happen to the Richmond?
Yes, sir, there has.
Mm-hmm.
Under the dam safety guidelines, we have to do what's called a dam break analysis.
Yeah.
And so we have to model the flow of water down the valley as if there is a dam failure. Mm-hmm. So irrespective of all these earthquakes, what would happen if there is a total failure?
Yeah.
and that's been modelled. So I think there's a report online that shows what the inundation areas look like.
Yeah.
They look at a number of scenarios. They look at a normal operating scenario and what the inundation looks like downstream. They look at what they call a rainy day scenario, which is if you have a 1 in 10,000 year flood, 1 in 10,000 year flood, and the dam fails.
Okay.
Right. And then that total dam break analysis is used to guide the what they call the emergency action plan.
So how far would it eat into the residential area of Richmond here?
Doesn't get as far.
It doesn't come near Richmond.
Doesn't reach this.
Providence main Culvert.
So can we just go back to the questions that people have submitted, and we'd just like to finish those if that's possible.
So another question here is that did the initial design miss the issues with the rock fill? Yes, it did. Right. Question here, I would like to ask that on completion, will there be public access to the dam or the viewing area to appreciate our beautiful countryside? At the moment, there is no public access to site. That's a matter for the TDC, and I'd imagine that the TDC will consider that. In fact, I think there's an obligation, isn't there, resource consent?
Yes, I think it's walking only.
Yeah. There's a question here. We have been told an estimate of the cost blowout on the assumption that Waimea Water Limited is able to build a plastic face dam. Is that a foregone conclusion? The concrete face was reviewed by TNT and Mott MacDonald. Yes, it was. And if the case, if we revert to a concrete face or stay the concrete face, what does that mean to the cost of the dam? It's within the current budget. So the current budget of 129.4 contemplates both options. So one question here, could some explanation be given in a practical layman's term about the need for drainage suitable material when the dam is actually meant to hold water back? I think we've sort of covered that, have we not? Everyone understands why we have drainage layers. Yep, good. So there's a question around the level of, could someone please explain the 25% cost increase in relation to the 13 million contingency in the budget at the December meeting, given that 60% of the cost overrun is with the contractor. So in fact, it's 78% of the contract is actually a lump sum price. So the contractor wears that risk. So it's Jim. So the cost of that big concrete culvert is a lump sum price, and Jim carries the unders and overs on that. If the subsurface geology is our risk, right? So it's measure and value. So we actually measure we pay for the geology and what's beneath the ground curtain, for example. We also pay for changes. So we have a lump sum price for the plinth, but if there's no ground beneath it, we have to find a way to make some rock to support that plinth. So recognising that most of the contract is a lump sum price, there are always going to be some variations in any civil project based on the geology that you encounter. So we talked. There's a question about the a PVC breaking down over time. I think we've talked about that already. And another question is, if the dam is not finished in time, which is looking unlikely, then with the reductions in water take, because the water take's dropped this year, we can only get less water out of the rivers, could we face an Auckland or a Northland problem in a drought similar to this year? And would there be an impact to the economy in such an event? So I think the answer is the water takes out of the rivers do drop this year. That's in law now, and so the minimum flows have gone up, water take's gone down. So there would be a much greater take, wouldn't there? So if we have last year's drought next year, yes, it's going to hit us harder for sure. We will be facing an Auckland problem.
Public liability insurance to Waimea Water, what sort of cover have they got?
Public liability.
Mm.
Yeah, we do a public liability insurance. I can't recall what that is, sorry.
In case there was a failure.
So we have a number of insurance policies. So we have public works, for example, to value the works. So if the works goes wrong, then we have insurance for that. We have insurance for public liability. I just can't recall what it is.
Okay. At the beginning, I was asking about some costs and that, and you said you had a slide there that showed us if we stop the thing now, what the cost is going to be. Can you put that up for us to see what that?
Just go back to the second slide.
Second one?
Yep. You're there. Yep. Yeah. So we spent 50 million, right?
You spent 50 million so far.
50.2.
Okay.
If you were to stop the project, you've got to firstly pay out the contractor, right? We've got a binding contract with the contractor, so we have to terminate the contract, demobilise, pay out the contractor's costs, whatever else. But then you can't leave it there, right? You've actually got to smash it all up, take it out. That's called remediation. So we then have to remediate the area, right? So at best, those two aspects are probably 20 million. So if you were to turn around and say, I don't want to do this project now, the least you'd pay is 70 million. And there's only one shareholder paying for that, and that would be TDC. And what's worse, you have to give your money back to the Ministry of Environment because they aren't getting their environmental flows any longer. You'd have to give your money back to Nelson City Council because they aren't getting what they want. So you have to return money to those parties, right? And so the TDC will be left paying that bill, 70 million bucks, by itself, without the money from Wellington or from Nelson, and still with a problem, right?
And then at half built, it's going to cost you 20 million to pull it down. When it's completely built, what's it going to cost to pull it down? Because it's got an end of life, you're going to have to pull it down at that and put it back to a river, aren't you? Is that not in the plan? I read it somewhere in the document.
My children, grandchildren, great-grandchildren will be using the benefits of the dam.
Okay. Richard.
From what you've said tonight, with the geology wasn't explored enough, and you expected, and until you open it up, you don't know what you're going to get. So it was pretty reckless, if not dishonest, for somebody to put in a P95 on that price at 82 million. Really, because they're, being a contractor, until you put a bucket in the ground, you don't know what the hell you're going to dig up. And generally you allow that provision for going. So a P95 to me was a very reckless thing to put in, if not completely dishonest, because there's no way that you can guarantee that P95. Well, not you, but
yeah, look,
whoever put that in.
I hear you, right?
You agree, or you hear
I don't know how the P95 number was calculated. I'm sorry. I mean, but when I looked at the contingency, it looked modest. Right. I know that when I come from the private sector, and I've worked in Australia and around the world.
You know how the cost overrun on your last project, isn't it?
Northwest Shelf. No, that's on budget. You're thinking of Barrow Island. Right. Yeah, and that costs more than the space station.
And it's not going to supply any water to the town because it's not going to reticulation.
No.
It's not going to have a power station.
No. So look, I can't talk to the number. I mean, I don't know who made those representations. I'm sorry, but it looked like a very modest contingency.
Mr. Drummond again.
I would like to wrap it up here. Is there anyone who hasn't asked a question who would like to ask a question? Those people who want to carry on asking questions can come and talk to us up the front, and we can let the rest go home. I think you've asked the questions.
Can I have a complete file on this project?
You're going to put these online?
Yes, yeah, and the video. So there's a video been going tonight, so that will be online too. Is there any, no, I've already
I want a
said.
folder on it, please. Can you give me the whole complete printout?
Sure, we'll sort that out.
Well, I'm standing for Parliament in the coming election, so I like a folder.
Good on you. Good on you. Is there anyone who hasn't asked a question who wants to ask a question? If not, I'd like to wrap it up now. Thank you very much for your time. We will hold another one in 2 or 3 months' time and give you an update as to where we've got to there. At some point, we would like, depending on the demand, we would like to actually have a controlled open day with buses going up and having a look at the site, etc. But the demand has to be there. Obviously, it's a construction site, and we've got to be really careful with people tearing all over the place. So it does put the fear of God into us as to what have we brought on ourselves if we do that. But
Much the same feeling we've got.
so if you do want to go and have a look at the site and you do want an open day, come and talk to us, or come and talk to the team, or send us an email, whatever. We obviously have to approach the landowners, because there's private landowners all around, to ensure that we respect their private property as well. So if there's nothing more, thank you for your time, and hopefully most of it's been informative for you. Thank you very much.